The basic concept is that we want the CPU to be busy always. We want that if some processes are waiting, these processes are waiting, we want them to assign it to CPU so that the CPU is always busy and the multi-programming can increase. Now the CPU is allocated the process by, first of all, there is a short-term scheduler. Then after that, once the short-term scheduler says, okay, this process has to be given, the dispatcher dispatches it from the ready queue, or it takes the control from the short-term scheduler and takes this process to the CPU. So if it is a uniprocessor system, there is no problem, one process may be running at a time. But when we talk about multi-programming, that is, we want multiple programs or multiple processes to run, then we want to see that in order or in what order the CPU maximizes its utilization. So we have two types of CPU, you can say, processes. One is input output bound, one is your computation bound. We have certain time which is given to it. See, I'll show you. There are CPU input output burst cycle. What it means, that when CPU burst is given, means the time which is given, what time the process takes in the CPU, and it is computation bound. So this is where the CPU burst is going on. Now the process is waiting, so this is the input output burst. Now again it is doing some task, or the CPU is operating on it, so it is CPU burst. Likewise, this goes on and on. So this is a cycle, and when the CPU burst end, there is a request to terminate the execution. Now what we see here in the histogram, we have frequency of the happening and also the millisecond, the burst duration. What happens at start, it is very high, then it becomes a kind of constant. We want that the CPU burst time should be in accordance with the maximum CPU utilization. So the input output bond typically has many short bursts like this, while the the input output bond, and CPU bond have large CPU burst. So in order to select the CPU shading algorithm, we have to know about this also. So what is a CPU scheduler? As we just said, that the process has to be brought into the memory first. This is done by long-term scheduler. Once they are in memory, they are to be put in the ready queue, and then now in this ready queue, one process has to be selected. This is done by short-term scheduler. Now once this has been done, this has to be given to CPU. This is done by the dispatcher. So these can be, the different form is, you can select the processes in terms of first in first out, in terms of process queue. So you need to have all the records of the PCBs, process control block, because you're dealing with processes now. There are certain types of preemptive scheduling, which is preemptive and non-preemptive scheduling. And see, in this non-preemptive or cooperative scheduling, what happens, the process is allowed to run to its completion. It is not being disturbed. It is never disturbed. It is allowed to complete, right? And there is no choice in terms of scheduling, because there is no preemption, but we'll see about that also. In terms of preemptive scheduling, the process, even if it is working, it may be temporarily suspended. It can be sent to a waiting state. From the running state, it can be sent to a waiting state. But what problem can arise? See, if you have process here, P1, this is updating its data and you have just preempted it. So P1 comes out from the CPU. Now you put P2 inside. So now P2 has taken the place of P1. P2 is on the CPU. Now it is being executed, or it is under execution. Now this P2 is dealing, or it is wanting to process the data, or it is requesting, or it is seeing the data of P1, but P1 was not updated. P was not properly updated, so there will be inconsistency what P2 will be viewing, because P1 is not updated properly. We have a dispatcher. Dispatcher is very important, because as we said, when once the ready queue is there, in this ready queue, which process has to be selected is devised by, or is formulated by the short-term scheduler. Now CPU, who is the authority, who is the component, who is the module, which is the module which takes this process to CPU? It is nothing but the dispatcher. So dispatcher is the module that gives control of the CPU to the process which is selected by the short-term scheduler. So what task it applies, or what are the process? First is the switching constant. This is P1, this is P2. P1 has to be taken out. That means P1, all the state, all the information has to be kept, and P2, all this information it has to be reinstated in the CPU. So we also ought to know, it may be possible P2 might have been reintroduced. So P2 might have worked along, it has been executed for certain point, so it has to be restarted again. So dispatcher has to be as fast as possible, because dispatcher is invoked for every process. As we said, long-term scheduler, it has low frequency, short-term scheduler has very high frequency, but dispatcher, in spite of being high frequency, or along with being high frequency, it has to be very less in the latency. That is the dispatch latency, that is the time it takes for the dispatcher to stop one process and start another running. This is the dispatch latency. We want it to be as minimum as possible.